Welcome to the Neverfail Continuity Engine Solutions Overview. My name is Mike Wrightson. I am the General Manager here at Neverfail. And for the next 25 to 30 minutes, we are going to go through a presentation that introduces you to Neverfail. We'll talk a little bit about the technology, and then we'll kind of wind it up for this presentation. So let's get started. So a little bit about our company. Neverfail is not a new organization. We've been around for over 20 years delivering successful implementations of Continuity Engine. Today we are in version 8.5 of our technology, which really attests to the level of maturity the technology is. So Continuity Engine is a mature product. It is in over 4,000, almost 5,000 direct customers worldwide. And we have a channel network that is growing every day. The idea here is that we provide a technology for continuous availability. So our group started in the early 90s, and they were doing work around Microsoft failover cluster. And they saw that there was gaps in the delivery of business continuity, namely that not all the technologies that were out there could successfully see all of the events that could potentially take out a business service. So they got together and started a software company that concentrated on filling in some of these gaps to create what we call application awareness, to be able to see these different events taking place, be able to respond to them, and then of course automate and trigger the failover process. So today we have, as we mentioned, thousands of customers, and pay attention also to our integration partners here. VMware is one of our biggest partners, and for years they had what they call the vCenter server, which is really a critical piece of their vSphere infrastructure. But they knew that vSphere HA and FT, which actually are powered by vCenter, weren't sufficient enough to protect the vCenter server itself. So they came to us and asked us to provide full HA and DR capabilities for that product. And in version 5, it was known as the vCenter Server Heartbeat. So we have thousands of deployments of vCenter Server Heartbeat for Windows servers out there. But that was just the beginning. We built a incredible list of names and partners that that trust Continuity Engine to be integrated into their technology, to provide continuous availability, to give them that level of protection for their very critical applications, because they know and trust that we are experts in these areas. So we have worldwide distribution. We also have select partners, and we have many different types of direct customers worldwide in every single vertical. The idea here is that everybody has the same problem. They have a critical application that needs to be protected, and they come to us for that. So why do they come to us? Well, because the technologies that are available out there are not sufficient to get you to that level of granularity where you can see all the different problems that could potentially impact the delivery of the business services. So if you look at different types of technologies, such as backup and restore technologies, they focus in on what we call data protection. So they are data focused technologies, and so they are fundamental to any business continuity technology. So no matter what technology you have, you still need to do backups. And the question is how fast can you get them done, right? And how fast can you restore them? So this is pretty much the slowest means of restoring data. So your RTOs, or your recovery time objectives, are very high with this. Now, they've done a better job at getting the RPOs, or the recovery point objectives, down, but it's still a big gap. So it takes time to do your backups, and it takes time to do the restores. But this is a fundamental technology to any business continuity strategy. Then you layer things like basic failover on top of this. Now you're getting to a place where you have recovery of the application servers very, very quickly. So your RTOs go down significantly, but your RPOs could potentially be high with these technologies. So these are things like clustering, like a Microsoft failover cluster, or semantic VCS, or fault tolerance technologies, even virtual availability, such as VMware HA and FT. So these are all based on the idea that we need to restore hardware, physical or virtual hardware, to restore business services. And that's really where they functionally are in the continuity stack. But again, they don't really see all of the different things that could potentially happen to those application servers. So that's where we come in. So Continuity Engine is a technology for what we call continuous availability. So what does that mean? So when you're looking at holistically an application, there are many different things that could potentially impact the delivery of the business services. So you could have, an application problem or maybe a networking problem, but these have to be identified and they should be corrected, or if nothing else, would be able to respond to those failures that would stop end users or other applications from accessing those services. So we provide what we call application-aware failover. So that is a technology that literally monitors all of these different internal things to the application server to be able to detect different types of anomalies happening, and then we can respond to them very quickly with recovery actions. Those recovery actions will trigger automation and orchestration to restore business services either locally or at a remote data center. So this is really about focusing in on the business itself to be able to restore entire business services literally within about 30 to 90 seconds. So now you go from a recovery-centric approach to business continuity to an availability-based approach to business continuity. So when you're looking at the different things that could potentially impact the delivery of the business services, you can't do this without understanding what's happening underneath the application, within the application server itself. So if you look at things like human errors and application problems, which actually cover multiple areas, such as availability of the application itself, the services, functional services, and even the performance of the application. These are three different areas that are very that power the application and are very critical to be looked at. But that's not all everything that you need to address. You also have hardware issues, you have networking issues, even operating system issues that could potentially take out the business services. So you could have corruption, logical corruption in the operating system, or maybe somebody just deleted some critical operating system files or overwrote them, and the application server stops at the operating system level. So these things are very, very critical that need to be actually monitored real time. But we're also seeing things like cybersecurity risks. So people writing viruses that delete files or encrypt the entire operating system, such as some type of ransomware attack. So these are all things that could potentially impact the business services, the delivery of the application, and also even potentially the data that is protected by this application server. So that's really where we come in. So we are a technology for continuous availability. So Neverfail continuous availability has a technology called Continuity Engine that is based on what we call a clone-based architecture. So what is a clone-based architecture? It is simply a snapshot of the original server. So we have an exact clone of it. We take it offline, so it's not visible to the end users. We bridge it with a dedicated network. We call that the Neverfail channel. And we replicate the data over to it real time. Now, so what's different about that than some of the other technologies that are out there? Well, think of it in these terms. If you had to build up another server with a completely different name and identity, there are multiple things that you may have to do to restore those business services, such as doing system state recoveries, also rehydrating the data, restoring somehow the security context of that server and its application so that it matches all of the users that need to access this. So these things have to be done and ensure they're done in order for a failover process to work and the delivery of those business services to function properly. So when you do that, you may also have to reboot the servers, which extends the RTO, or the recovery time objective, and can make it much longer than it really needs to be. With a clone-based architecture, though, by Continuity Engine, it eliminates a lot of that complexity. It typically takes the original server, we copy it, we bridge it, and then at the time of failover, the secondary is brought online. All we have to do is spin up the services. In a local HA, it even restores the same IP address. If it's in a different geographical location, then all we have to do is just change the IP address and update the DNS. But functionally, this is exactly the same server, so we don't have to reconfigure it. We don't have to do additional configuration changes within the application server. We don't have to make it look like the old server because it is the old server. That means the security context is always right. We're synchronizing all of the user accounts and their groups over. So everything comes together, and the recovery time objective is extremely low. So we're talking about 30 to 90 seconds. Now, once you add continuous replication to that, now we can get to a point where your RPO, or the recovery point objective, is very, very low. We're talking milliseconds between the different nodes in the cluster. So these two are the cornerstone features of our continuous availability model. Then if you add continuous monitoring to that, now it brings a whole new level of availability by being able to see different anomalies as they're happening real time within the application server itself. So why is that important? Well, we can see what's happening there. We can then respond to those by orchestrating a failover process. So with that in mind, you have the ability to be able to deploy these in different data centers. There's no distance limitations. We give you very flexible deployment options, which we'll talk about next. And also it's patch management ready. So you can actually deploy this. You can manage those passive nodes. You can get them up and running, and you can patch them and do configuration management as if they were separate, completely different identities. All of this really is designed so that you can keep users working all the time. And if there is an incident, we can restore business services very, very quickly. So there are three different types of topologies. There are what we call the local HA topology, which is essentially the clone copy is sitting next to the production server in a local area network, basically on the same subnet. It is fully application aware failover. So it is designed so that we can have rules that allow us to trigger the failover processes and be able to restore business services basically automatically. So you don't have to have any user intervention whatsoever. The rules provide you with the intelligence layer that you need to see these anomalies that we just talked about a few minutes ago. So with that in mind, we can easily bring the secondary online. We can spin up the services, assign the same IP address, and boom, you're back in business. So within 30 to 90 seconds, you have fully automated recovery, and you just get, from an end user perspective, the administration team, they just get an email that says it was done. So what about multi-site disaster recovery? Well, it is very similar to HA in the fact that you have a pair configuration with a clone, but it's at a different geographical location. So you can stretch this cluster across very wide geographical locations. We actually have a customer that is stretched halfway across the planet. We have no latency issues with this. The typical difference is in a disaster recovery is by default, it is the push button initiation. So it is not rules-based per se, but once you push the button, the orchestration process kicks in and you have failover within about 30 to 90 seconds. It also is bridged over what we call an add-on to Continuity Engine, which is called WAN Smart. So WAN Smart allows you to compress and deduplicate that information that's being replicated over the wire up to 30x, which allows you to scale your bandwidth and allows you to be able to minimize the amount of replication traffic on your network over your wide area network. So that is multi-site disaster recovery. It also gives you the ability to do DNS injection. So once you switch over to your secondary server, it assigns a new IP address, and it then updates the DNS server, and boom, you're back in business. All of the users and applications are now redirected to the secondary server. It is up and running, and you're functionally back in business again. The alternative to that, and which is a really popular option, is what we call tertiary for business continuity tertiary deployment, which is a 3-node configuration. So with that, you get the best of both worlds. So you get fully application aware failover locally, which covers all those things that we just talked about a few minutes ago, all the local incidences that could happen, sometimes referred to as the small Ds, the small disasters. But then you have the third copy out at a different geographical location, i.e. a different data center, and you can recover from an incident where you've lost the entire data center, or what we call the big Ds, the big disasters, right? Natural disasters, pandemics, things like that. So all of these things come together with Continuity Engine, and they provide you with a proven technology that is now in version 9 that provides you this continuous availability model across the board. So now let's talk a little bit about how Continuity Engine works. So there are 2 different approaches to Continuity Engine, or 2 different parts of this. There's the management layer, and then there's the actual end, the protected application servers themselves. So Continuity Engine starts with a deployment of the engine management service. The engine management service essentially is just it's a portal service. It runs on HTML5, Tomcat server. It's very thin. It can install on a shared Windows server. It doesn't have to be dedicated. It could even install on a Windows 10 desktop. That's how thin it is. But what it does do, though, is it gives you the ability to manage and deploy Continuity Engine onto your protected servers and create this cluster, if you will, of these clone copies of your servers. And it manages the replication process and these other things. So the first thing that happens is you install this, you log in with your AD credentials, and then you select your primary server. And then you do a remote installation of Continuity Engine onto that production server. Now, this happens in the background. You don't have to worry about it interrupting your production server. It is a silent install in the background. So you go through the first wizard that allows you to do this. Then you go through a second wizard that allows you to extend the cluster, to build out that copy, if you will, and then create the channel to allow for the monitoring and the synchronization of data. So it asks you a whole bunch of questions. It interviews you. So if it's local HA, it just basically asks you for the channel IP addresses for the primary and secondary. If it's DR or tertiary, you have to add some additional information, like what the new IP address for the server is going to be, including its subnet mask and its DNS server. So it goes through all these and asks you for all the IP addresses. And then it saves that information to the primary server Neverfail configuration. So once you do that, there are a couple of different options that happens to extend your cluster. You have what we call a fully automated process. So if you're in a VMware environment, you can register a vCenter with Continuity Engine Management Service, and it can use the vCenter inventory in vCenter APIs to, 1, to select the server that you want to protect, and 2, you can use vCenter APIs through the Engine Management Service to copy that server for you, to create that clone copy. So that is what we call fully automated deployment, and it's orchestrated. Once you hit the finish button, it goes out and it starts the entire process and talks to vCenter. Then there's what we call an assisted deployment method. So essentially you go through the same wizard. At the end of it, when you hit the submit button, it will tell you that it's time to clone the production server. So if it's a physical server, you can go now and go over and use a bare metal restoration tool and just drop it onto your, onto your new hardware, if you will. If it's a P to V, you can use vCenter Converter. If it's if it's in VMware or other tools to create a virtual copy, if you will, of that and stand it up on another host. If it's a virtual machine, all we do is call our VMware administrator or hypervisor administrator and say, I need a hot clone of the production server, and you need to put it on this, this host in this network. So once that's done, you boot up the server. Continuity Engine starts first on the secondary, and it is automatically assigns the channel IP address, and it goes passive. It becomes a passive node. So it does not start the application itself, but what it does do is it goes through what we call a full system check. So it basically does a differential sync between the primary and secondary server so that we've mirrored up the protected data sets, and then it goes into full replication mode. So now anything new from the production server application data that we're protecting gets replicated over to the secondary real time. Now, if something happens to the server, in a local HA, remember, we have these rules here. So the application management framework is our, our tool, if you will, that's built in that monitors the health of the server, the network, the application, and even available resources to those applications within the server itself. And they're implemented as threshold rule sets. So we provide you recovery actions that can be triggered based on those. So those threshold rules, if they check them every X amount of minutes, they're good to go. They just keep executing every X amount of minutes. But if the condition fails for some reason, then it goes into recovery actions. So it would be, you could either send an alert out, you can restart the services or the application services stack, if you will. You can even fail it over to another copy of the server. So all of these kind of come together. You can custom configure these if you want to, but the idea here is that you have these threshold rule sets that provide these recovery actions that respond to these failure events. So in a DR, it is a push button initiation. So you can have it automatic to a different geographic, but that's more of a, for example, that's more of a HA that's stretched, right? So, but in DR, usually by default, it is a push button initiation, but the same process happens. So once we ask the secondary to come on or become active at the DR site, the same orchestration process happens. So the recovery, regardless of its being local or remote, is about 30 to 90 seconds. So if something happens, Continuity Engine will then bring up the secondary server. It actually reveals it to the network, spins up the services. In a local HA, it actually assigns the same IP address as the primary. In a DR, it'll go through and actually add the new IP address, its subnet mask, and of course its DNS server. And while it's doing that, after it does that, it actually goes to the local DNS server and actually updates the A record. So it has the new IP address. So now we have a secondary that's active on the network. So in a local HA configuration, all you have to do is basically the secondary server will just be monitored by the primary when it comes back online. If it's in DR, you can actually do what we call a switch back. So switch back basically happens after everything replicates back to the primary server. And you can just basically hit a button again and you do this and it switches over in 90 seconds or so. So the first thing that would happen is that you would bring that server back online again. The channel connects, that synchronization process happens, that full system check and then full replication. And then in a local HA, the primary, as mentioned, will just sit there and monitor the secondary. It will become available and raise itself to active status if something happens to the secondary. In the DR, you just push the button, And 90 seconds later, your users are back to the production server with no loss of data. So this is really why Continuity Engine is so powerful. So you get the ability to have fully automatic application-aware failover, and you can fail over full applications across to different data centers, regardless of the distance, and it all happens within about 30 to 90 seconds. So now let's talk a little bit about the protection scenario. So of course, we can protect a individual server. As we mentioned, we support P2P, P2V, V2V. It is storage agnostic, so as long as we have direct attached storage or a SAN LUN assigned to that server, we can replicate that data. And so this gives you a lot of capabilities. So you can, you can have virtual machines with their local disks. You can actually have SANs, a LUN assigned to that virtual machine, or even to a physical server. But regardless, we can support it. We also can give you the ability to protect entire application stacks. So one that we typically use is a SharePoint farm, right? Where you have the front end servers, web services, you have SharePoint, core, you have some index servers, and you have some other supporting applications that are add-ons, but all make up kind of this application farm. So in that case, we can protect all those applications that run on Windows and be able to fail them over to a remote location or even internally. And then of course, we can protect an entire application community, right? So all of your applications within that are running on Windows can be protected, and if you lose the entire data center, we can do a full site failover. So these are really why Continuity Engine is such a powerful technology, is we provide you with these different types of protection scenarios along with multiple topologies and network configurations that can be supported with Continuity Engine. So let's now briefly review. With Continuity Engine, the whole premise of this is to get you to application awareness. Continuity Engine has some of the technologies that we saw in the pyramid slide. So we have data protection built into this. We have clustering capabilities. So we take these through this true clone-based architecture. So we bind those together along with putting this application-aware failover on top of it. This now gives us a technology that's unique in the industry. The application awareness continues to evolve. We continue to add more functionality to Continuity Engine. It provides you with full network protection, so we can see what's happening on the network. We can control bandwidth on how much we're taking using WAN Smart. We give you an easy to understand technology. So there's not a lot of whiz-bang features that you're not going to use with other technologies. They've built technology up so that you can do these with all these different features, but you're never going to really use them. So with Continuity Engine, we provide you with that capability. So with that in mind, we have also full site protection capabilities and also VMware integration. So that concludes our presentation today. If you have any questions, you can reach out to the Neverfail sales department. You can also email us at sales@neverfail.com, and we will be more than willing to answer any of your questions. Until the next video, thank you and take care.